In today's lecture, we will learn how to do data visualization in SAS. Specifically, we will learn how to apply proc SGplot and proc SGpanel to produce bar charts, histograms, box plots, scatter plots using data SAS.help heart, and series plot using data hospital visit. Proc SGplot can only produce a single plot, and proc SGpanel can produce panel which contains multiple plots. The basic form for the procedures are proc SGplot / SGpanel, data equals the dataset name, statement, and then run. Let's look at the bar chart first. The simplest bar chart can be used to summarize the frequency for a single variable, usually for ordinal and categorical variables. The key statement is VBAR or HBAR variable name. VBAR produces a bar vertically, HBAR produces bars horizontally. Next, we'll look at SAS. Here in SAS, I have the log as well as the data visualization script with the SAS code. I've moved these windows so that once I produce results, I can move them over to here. The first thing we need to do is to read in the two data sets we'll be using. The first one comes from SAS help, and we've seen this one before. So running the data step. Checking our log, we can see that it was read incorrectly. The next is the hospital visit data set, which is located on Canvas. First, you'll want to make sure that you do set the directory to where you have the file located. And again, checking our log just to make sure that the data set was read incorrectly. Next, we can look at the bar chart example. We'll demonstrate the usage using VBAR statement. In the first example, we want to look at the smoking status among patients who have heart disease. There are 5 different categories for smoking status. Running this right here. And then again, we're going to move this just to make it easier to see. So here we see the 5 different levels for smoking status. And notice that VBAR stands for vertical bar. If we were to change this to an HBAR, we would get a horizontal bar plot. So again, running the VBAR, notice the y-axis displays the frequency count for each of the categories. The x-axis is going to be sorted alphabetically by default. We can add a title and footnote statements to make the graph more informative. This can be done here, looking at the second example. Notice here we have changed our title to be the bold red color, smoking status frequency. In the footnote, we have justified left, which moves it to the left, figure 1 frequency of smoking status. So the style of the text can be customized. The bottom plot displays the title in bold red color, as we just saw, and a footnote is added to the bottom left with a plot to state what the figure is for. Now, one thing to note here is we are just starting to learn about bar charts. Whenever we have a variable that is ordinal, such as smoking status here, we want to make sure that we do list those bars in their natural ordering, and we'll see how to do that later on. So we would want to go from non-smoker, light, moderate, heavy, and then very heavy. Again, looking at the PowerPoint slides, we see that comparison for the top and to the bottom. Let's look at an example with the group option. This time we will add group is equal to sex to look at the smoking status by gender. By default, the procedure produces stacked bar plots. Each smoking status bar has 2 proportions, one for each gender. The legend box contains information in color for group gender. Again, we'll look at this in SAS. First, we're going to look at the by group default. Running the code. Here we have for, again, each of the smoking statuses. The red represents male, and the blue is representing female here. Running the next set of code, Group Display option can change how the bars are displayed for groups. Here, we specify to display by cluster in the bottom example. This will generate side-by-side bars by groups. Therefore, for each smoking status, there are 2 bars by gender. The seg label option adds the counts to the bars, so you don't have to compare the height of the bars to the y-axis to figure out the frequencies. This is shown in the plot. And again, we see that side-by-side comparison on the PowerPoint slide. There are more options for VBAR statement. In this example, we would like to examine the age when the patients got heart disease by smoking status and by gender. So we'll again look at the SAS code. First, running the SAS code. The response option changes the y-axis statistic from smoking status to patient age. The stat option specifies the statistic for the y-axis, and the limit stat option specifies the statistic for the limit lines. In this example, the plot displays mean and standard errors for age. The baseline option specifies the response axis intercept for the baseline. In this example, we want to check what combinations have a mean age smaller than 45 years old, so we specify baseline equal to 45. We can see many smoking status and gender combinations have a mean age less than 45. There are more options for VBAR statement. For more information on VBAR, please use the link located here in the PowerPoint slides. Each bar will be similar. Next, let's look at the histogram. The simplest histogram displays the distribution for a single variable, usually for continuous variables. The key statement is histogram and a variable name. We will look at the SAS code. Starting out, we'll look at 2 different examples. We'll start with the first example, which is the simple histogram. Running the code. In this first example, we want to look at the distribution of the patient height. Notice we have histogram and then the variable name height. From the plot, we can see that the patient heights range from about 50 to 75 inches. The interval for the patient height is 1 inch. So notice between 55 and 60, we have 5 different bars. The y-axis displays the percentage for the height intervals. So, for example, if we look between 59 and 60, we have a little over 4%. If we want to modify the intervals for the histogram, we can use the bend width option. Let's look at this next example. In this example, we specify bend width equal to 2 and change the interval to be 2 inches. The histogram has less bars compared to the original plot. The scale option specifies the scaling that is applied to the y-axis. In this example, we use count. We can see that the y-axis changed from percentages from the previous plot and count to this plot. Again, here on the PowerPoint slide, we see the comparison of the 2 different. In the bottom one, we change the bend width to be equal to 2, and we also change the scale to be count. We always want to check the distribution of the variables before we do any kinds of analysis. The density statement creates a density curve that shows the distribution of values for the variable. Normal distribution is used by default. We'll again look at the SAS code. In this first example, we will add a density curve from the normal distribution to the histogram. We can see that the patient height is normally distributed. Notice that the density curve was added by using this line right here. In the second example, we would like to look at the distribution of height by gender. We use the group option to display this histogram by gender. By default, SAS produces different colors for groups and label them in the legend. Transparency option adjusts the colors to make the overlaid portion to be identified easily. In this plot right here, we can see clearly the separation between female and male. We can again see those comparisons here on the PowerPoint slide. If you want to generate separate histograms by groups, you can use proc SG panel with histogram statement. The key statement is the panel by. By default, SAS will arrange the panel plot the best way it can be displayed in the panel. In this example, we separate the histograms by gender for patient height. The procedure produces a 1-row by 2-column panel. We can modify this by the rows option. So notice currently the rows option has been commented out, but we can add it back in. We can specify row equals 2 to produce the 2-by-1 panel seen here. There are more options for histogram statement. For more information on histograms, please see this link located in the PowerPoint slides. The simplest box plot summarizes the distribution of a single variable, usually for quantitative variables. The key statement is VBOX HBOX in the variable name. We will use VBOX as an example. In the first example, we want to look at the distribution of patient height. Running the code. From the plot, we can see that patient heights range from about 50 to 75 plus inches, which matches what we saw in the histogram. The mean and the median are at about 65. The interquartile range is from about 62 to 68. By default, SAS sets the whiskers at the lower and upper fence, and the outliers will be displayed. We can customize the plot. We can modify the style of the symbols and lines. For example, the symbol is changed by specifying symbol equals plus in the mean options at the bottom of the plot. Running this code. We can use the extreme option to extend the whiskers to the true min and max observations as seen here and here. Therefore, no outliers will be displayed in the plot. So when you look at the box plot, don't rush to interpret the results. As we can see, comparing the two different plots, the whiskers and points beyond the whiskers can have different meanings. Try to understand how the plot is generated first, then you can do the interpretation. If we want to look at the distribution of height by gender using the box plots, we can either use category or group option. We can see that category option generated the plot with gender value as x-axis tick marks and same color for different categories in the top plot. Looking at SAS, we will first look at the category option. As stated before, we can see that the category option generated the plot with gender values as x-axis tick marks and the same color for different categories in the top plot. Looking at the group option, group option displays the gender by group using different colors with legend box to indicate the gender group in the bottom plot. There are no tick marks for gender. The difference is because SAS treats the variable differently in category and group options. So if you try to add an x-axis statement with the type equal linear, this will only work for the category option. Group option treats the variables as discrete, so this won't match the linear type for x-axis. Let's look at another example which uses both group and category options. Here we use gender as the category variable and smoking status as the group variable. So the genders will be displayed on the x-axis. First, running the code. For each gender, height is further divided into smoking status groups. Same colors are used for the same smoking status between genders. The colors for smoking status groups are explained in the legend box, seen down below. We can see that the order of smoking status for groups are different between female and male. To make the plot better, the group order option can be used to sort the order. Let's look at the second example. In the second example, we limit the plot to only include observations which have non-missing smoking status. Apply a customized format to smoking status variable and specify the order to be ascending. We can see that female and male now have the same order in smoking status. There are more options for VBAR statement. For more information on VBAR, please use the link located here in the PowerPoint slide. The HBox statement has similar options. The scatter plot displays the values of two variables along two axes. The pattern of the resulting points may reveal any correlation present in the data between the two variables. Usually we summarize two different quantitative variables this way. Looking at SAS, we can see that this key statement is scatter, and the variable names for the x-axis and the y-axis follow. In this first example, if we run the code, we want to look at the patient height versus weight. We can see that there is a positive correlation between height and weight, which is what we would expect. Let's look at an example with the Reg statement for adding regression lines and group option for both scatter and Reg statements. Group option and scatter statement separates gender into female and male and displays observation points in different colors. Looking at the SAS code, the Reg statement adds regression lines to the plots. The group option and Reg statement fits two separate regression lines for each gender. No markers option suppresses the observation points to be printed again. In this example, if we remove the scatter statement and the no markers option in the Reg statement, the procedure will produce the same plot. Let's look at more options for scatter statement. One way to visualize values of interest is to display those values with label in the plot. Here is an example to display the smoking status and weight status for patients who had cholesterol levels over 350. First, we need to create a new variable that contains the information we'd like to show in the plot for the observations with extreme values. That is done here in the data step. Data step is used here to create a new variable called label with smoking and weight status for cholesterol levels over 350. All other cholesterol levels have empty values for the variable. We then apply this variable to the data label option in the scatter statement. Where statement is used to zoom in on the plot for high cholesterol and high weight values. We can see that 6 observations have labels in the plot. There are 2 female non-smokers and 4 male heavy to very heavy smokers, and they are all overweight. Options that we have learned about for other plots, such as group display and group order, can also be applied to scatterplot. To learn more about the scatterplot using proc SGplot, please use the link located here in the PowerPoint slides. Let's look at series plots. They are often called time series plots. They are graphs used to display the change or trend of measured values over time. Usually the x-axis is some measure of time, such as hour, day, and year. The key statement is series, and the variable names for x and the y-axis. Looking at the first example. In this example, we'd like to look at the number of inpatient visit over time for Hospital A. We have monthly count of inpatient visits for the hospital. The date variable is what we would like to use as the x variable, and the inpatient is the y variable. We can see that there was a decreasing trend before the year 1994, followed by an increasing trend between the year 94 to 99, then followed by another decreasing trend to year 2002. Then the inpatient visits turn to be stable afterwards. The peak happened in 1999, so from the plot we don't know what happened, but the question there might be something that happened during that time frame that deserved further examination. What if we also want to display the outpatient visits in the same plot? We can definitely add another line to the plot. However, in general, outpatient visits are much higher than inpatient visits. So if we use the y-axis with the same scale for both variables, the line for inpatient visits will be flattened and we wouldn't be able to see any trends due to the high value of outpatient visits. Therefore, we'd like to display the 2 lines in different scales. We can do that using this code here. The option Y2 axis, seen here, assigns the y variable to the secondary vertical axis. We can see from the plot that the left y-axis ranges from 200 to over 120 patients, and that the y-axis on the right ranges from about 10,000 to 70,000 outpatient visits. The line attributes option helps to customize the line attributions. In this example, we only change the line color to blue for inpatient and red for outpatient to differentiate between those 2 lines. From the plot, we can also see that the trend in outpatient visits is sometimes different from the inpatient visits. In the second example, we use the group option. Similar to other plots, the group option helps to generate separated lines for each hospital. The series plot displays the outpatient visit trends over time by hospitals. We can see from the plot that Hospital A has the least number of outpatient visits, compared to Hospital B and C, which are on a similar scale. Panel plots can be useful to display the groups separately in different panels. This requests a different procedure called SGpanel as to what we've mentioned before. First, running the code. The key statement is panel by followed by the variable used in the group option previously. In this example, we'd like to plot the inpatient visit over time for each hospital in separated panels. Option row in the panel by statement controls the total rows in the panel plots. Here we specify rows equal 3 and we get a 3 by 1 panel plot. To learn more about series plots, please use the link located here in the slides. I'd like to introduce the usage of ODS styles on controlling the appearance of SAS output with an example. ODS styles are produced from compiled style templates written in proc template style syntax. First, running the code. The style template is a collection of style elements that provide specific visual attributes for your SAS output, such as font and color. The default style for HTML is HTML blue, which you have seen in previous examples. Here in this example, we repeat the example on page 11 and apply the style called PowerPoint Light to the ODS HTML statement. In addition, we apply format to smoking status and specify the group order to be ascending. Comparing with the output that we saw previously, we can see that this style applies different color schema and signs in the output. X and Y axes are labeled or bold. This plot looks nicer than the original one using the HTML blue style. There are many different built-in styles in SAS. You can also define your own styles, which we are not going to talk about in this lecture. To learn more about the ODS styles, please use the link located in the PowerPoint slide. Rather than comparing numbers from tables, plots can show the data and tell the story more vividly. There are many plots that you can apply to visualize the data. Sometimes you will need to compare different plots and different options to choose those which can best represent your data. Too little information in the plots is not enough to tell a story, but too much in the same plot can cause confusion. We need to consider how to balance between the complexity and visibility to include as much information as possible, while we can clearly display everything in the plots. Also, to enhance the appearance of the plots is important too. Color, font size, type of lines, signs, and other elements all play an essential role in the plot. Hopefully this lecture can help you learn how to generate basic plots. You will be able to learn by yourself in the future how to make your plots more presentable.